This video is on the volume of rectangular prisms. This is the first video under volume. All right, we have two diagrams here, one with one and one with one, two, three, four rectangular square shaped figures. Volume, when you're finding volume, you want to know how much it takes to fill it up on the inside. How much it takes to fill it up inside. Volume is the amount of the three-dimension space occupied by an object. Volume can also be referred to as capacity, how much it holds. The base of a three-dimensional object names the shape. A prism has two bases which are parallel to each other and they do not touch. The area of the base is represented by the big B. The big B. All right, so if we look at, they want us to shade the base. Let me find a colored pencil or something. I'll use this highlighter. We want to shade the base, and it's a rectangular base. So I'm going to shade that right there. There's the base, and it's rectangular. Okay, and to find the base of a rectangle, we know it's the area's length times width. So length times width here would be 9 times 4.5, and that's 40.5 centimeters. All right, this one right here, here's a base here. That's what it sits on. Here. And that would be 7 times 16. This is a rectangle base. And that gives us 112 yards squared. These are squared too. No, it's not. That's not squared. The whole thing would be squared. And then this one with all these 8.5s, that means they're the same on each side, so that makes this one a square base. A square base. And this one's 8.5 squared. And that's 75.25 meters. All right. So rectangular prisms, the volume can be determined by finding the area of the base and multiply it by the height. Of the prism. In a rectangular prism, the area of the base can be found by using the formula B equals base times height. The formula can be written as V equals base times height, and we're going to describe each variable. This is the volume of the prism. The area of the base. And the height of the prism. So that's the three things. But I'll show you a way that's the same way, but a little bit simpler for you guys. Okay. All right. We're going to take these three examples right here. You know, they said the volume is the big B times the height. Well, in most all cases with rectangular prisms, you can do the length times the width times the height. So all you really have to do is multiply the three numbers, the length times the width times the height. So that would be 15 times 10 times 12. And the volume is going to give you, when you multiply those three together, is 1,800 feet, and volume is cubed with the little 3. Okay, so the formula is going to be the volume equals the length times the width times the height, which is 21 times 21 times 6.1. So the volume is going to be 2,690.1, and then that's millimeters cubed. Volume is cubed, area is squared. The volume equals the length, the width, and the height. And the length and the width is the base. That's what it is. So we have 9 1/4 times 4 times 2. And when we multiply those together, we get 76 inches cubed. All right, down here, a rectangular prism below has a volume of 408 cubic inches. What is the height of the prism? So we know that the volume is equal to the length times the width times the height. We don't know the height, but the volume is 408. The length is 3.4, and the height is, the length is 8, the width is 3.4, and we're looking for the height. Now we know this right here. We can put that in our calculator, just like we've done before. Right here, we can put 3.4 times 8 times x, and then minus 408 alpha, and we get 15. So the height is equal to 15. All right, and if we did it the other way, let me get this cleared out. We could say 3.4 times 8, and that's 27.2. So now we have 27.2 h and 408. And then we would divide by 27.2, and h would give you 15. Use your understanding of volume to determine the missing dimension in the rectangular prism. So here we are again. We got volume equals the length times the width times the height. The volume is 2,736 equals, we've got the length is 24, then we have x, and then we have 1. So if we put that in the calculator, let me clear it out. We've got, you got to put it in parentheses, 24, x, and 1. And then we're going to minus 2,736. Enter. Make sure the A comes up. And you get, oh, let's go back. See something I missed. Something y'all probably would have missed too. This is inches and this is foot. So they have to be the same. So we have to change this to 12. So let's go down here and put this to 12. Glad I caught that. Now let's re-enter it. 24 x and 12. 24 x and 12 minus 2,736. Enter, alpha, enter, and you get x is equal to 9.5 inches. This one's inches as well. All right. Chelsea's building a sandbox for her backyard that will be 8 feet wide, 6 feet long, and 3/4 feet tall. To fill the sandbox, each bag of sand contains 5.5 cubic feet and costs $3.90. How much will it cost for Chelsea to fill up her sandbox with sand? So what we do know is the dimensions. And that is 8 feet by 6 feet by 3/4 feet. And then we know a bag of sand contains 0.5 cubic feet and cost $3.90. What we need to know is how much it will cost to fill the sandbox. All right. So what we need to do is find the volume. So the volume is equal to the length times the width times the height, which that would be 8 times 6 times 3/4. So when we put that in the calculator, 8 times 6 and 3/4 is 0.75. So that's what I'm going to use. I get 36. So the volume equals 36 cubic feet. Now we want to know how many bags at 0.5 cubic feet is going to fill that 36 up. So we take that 36 and divide it by 0.05. And that gives me 72 bags. And then we take those 72 bags and multiply it by the 390. So it's going to cost $280.80 to fill up that sandbox.